Good afternoon, and welcome to our third keynote. I hope you've enjoyed the discussion so far around all the other keynotes and the presentations. I think this has really been a very inspiring discussions. For those who joined us today, my name is Kurt Fendt, and I'm the Executive Director of HyperStudio for Digital Humanities here at MIT, the group that has been organizing this conference along with the Communications Forum at MIT and the Comparative Media Studies program. It's a great pleasure to introduce Martin Wattenberg. Unfortunately, Fernanda Viegas is not able to join us today, but they have worked together so closely since 2003, as I've learned. So Martin can definitely fill in, with Fernanda's part. As I'm sure there's probably no one in this room who does not know Many Eyes, the visualization tool that has really changed, I would say, the way people look at and use visualizations, where they can upload their own data and try out different ways of visualizing that. And this is, connected to some of the aspects that we've talked about already at the conference, empowering the user to give the tools to try out and ask different questions to the data. And this is clearly a tool that has been part of a number of projects that Martin and Fernanda have developed over time, tools that brought the visualization tools to the masses, and also visualizing data that is in the public domain. And yesterday, Ben Schneiderman was referring to the stock market visualization that he did along with you. And there are several other ones. And projects like Flickr Flow, looking at the images and the colors in images that were posted on Boston over the seasons is also another very interesting example. And you have actually one of those examples in the program in the front. But also textual visualizations and other kinds of visualizations that use images in an artistic way. What's really exciting is Martin and Fernanda have just created their new company, Flowing Media. It's rather new. And as you know, before they worked at IBM. But they're also very well known for their media artwork and visualization as media art. Their work has been exhibited at several famous institutions, the Museum of Modern Art, and several other ones. So please join me in welcoming Martin Wattenberg.
Thank you very much. I come at this from a slightly different background than I think probably many of the people in the humanities do. My background really is in mathematics and science. And so what I'd like this talk to read as is a kind of extended thank you note to the humanities associated fields for influencing the kind of visualization that I've done, I think that Fernanda has done, that we've all been doing in the visualization world. I think it's very easy to frame some of these discussions as what can visualization bring to the humanities, and I think that's an important thing to think about. But equally much, we can ask, how has the humanities, how have the arts, the social sciences influenced visualization, which really started out as a very kind of hard science or mathematical tool. So with that, let me just give you the theme of the talk, which is ask not what visualization can do for you, but what you can do for visualization. I want to give a very sort of enthusiastic and kind of non-critical view of good things that have happened from thinking about visualization as a cultural tool. So I want to start with a little demo of finding culture where you may not expect it. So this is Google. It's a very distracting little logo right now. But one thing that's nice about Google is they're always coming up with cool features. A recent feature is Google Suggest. And the nice thing about Google Suggest is if you type in a word like why, it'll autocomplete and suggest a whole bunch of questions you might be thinking of asking. Or not, I don't know. But the interesting thing is what it's doing is, I think they're a little cagey about it, but it's looking out of the web and they're saying, what questions have people asked frequently? And it turns out that's a very interesting lens to look at the culture with. So let's actually take a look at a visualization of that. This is something called the Web Seer. You can find it online at hint.fm/seer. Let's type in some words. Let's just try. How about, let's see, is he versus is she? And, you sort of find some interesting commonalities here. Everyone's trying to figure out, are they the one? It's interesting. There's a little more, is he in love with me, and is she cheating? The size of the arrows in this case are indicating the number of results that Google would return for these searches. It turns out this is actually quite an interesting lens. Let's keep looking at some other things. Let's kill this search and try a new one. How about, say, once people have met, let's look at is my wife versus is my husband. And actually, this becomes a slightly scary portrait of what people are worried about. And it's interesting. There are very few happy things here. I guess pregnancy is good, but it's depressing, and the differences here, I think, are significant. We can sort of look at gender relations in other ways. What about children, for example? How about is my daughter versus is my son? You can think, what is going to pop up for is my son? That's kind of interesting, too. And, it's nice that both boys and girls have a chance to be gifted, but looking at the difference is interesting. You can sort of look at this in other ways, too, maybe from a more personal perspective. What are people looking for themselves? Let's try how to be. OK, these are a bunch of good things you might want to be. How about how not to be? Or I'm sorry, how to, let's try how to pretend to be. This is one of my favorites. And what we see here is the intersection between how we want to look and be is happy, which is food for thought. We can sort of make this a little bit simpler. We can say, how about how to versus how not to. And here, the intersection of things that people are trying very hard to do and not to do is to get pregnant. Let's look a little more. One thing that's interesting is to think about how people view celebrities. Let's see, what questions do they have? Where do their paths cross? Let's say Madonna versus is Einstein. And the interesting thing is Jewish. This is not an accident, by the way. Pretty much any pair of celebrities you come up with, like the question everyone wants to know is, are they Jewish? I don't know exactly what this means, but it's true. The second biggest question is are they married? People want to know if they have a chance with Jennifer Lopez. So it becomes interesting. You can also look at this politically as well. You can say, for example, we know that we're a divided country, but let's see whether there's any common ground between Democrats or Republicans. Let's see, Democrats are, well, socialists, whatever. Republicans are, aha, OK, we can see. This is where the country comes together. OK. So, the theme here is really that by looking at text, you can get at an awful lot of meaning. And I want to talk about some other ways to do this. One of the things that has been interesting for me is that I started out really thinking about numbers, turning numbers into pictures. But through a bunch of projects, I discovered people were very, very interested in looking at text. So as Kurt mentioned, Fernanda and I have a project called Many Eyes that lets people visualize data. When it launched, we only let people visualize numeric data. But people started uploading all sorts of text anyway. And so we decided to develop techniques that would let people see text the way they wanted. So I'm going to go through a couple of these. Here is one. Let's talk about the word tree. So the idea behind the word tree is you start out with some text, let's say Romeo and Juliet. This is actually Shakespeare's original poster. And you have a search term. So let's take the term if love. Where does that occur in the play? 3 places. If love be rough with you, be rough with love. How do you collate these? Well, I mean, this is a sort of standard keyword and context view, but you can actually turn it into a tree like this, where you say, OK, I'm going to show that if love B is the beginning of all of these, the B is there all the time. And then blind actually occurs twice, which already is a little bit interesting. And let's see what that looks like when we start applying it to other texts. So a good example is, let's see, that's not a good example. Let's look at this one. Let's start out with the King James Bible. This is the entire King James Bible. So counting punctuation and words as tokens, that's about 1 million tokens. And let's explore this thing. So we started out with "and God." This is one of the sort of beginnings that was suggested by one of the Many Eyes users. And we can start clicking through on this. We can sort of look, what is God actually saying, particularly to Abraham? We can find other things. We can sort of find the famous phrase at the beginning, God, let there be light. We can see the whole creation by fiat there in one big diagram. It becomes a way to really sift through this text in a totally different way. It's also kind of a hypertext system as well. If I do a shift click here, I can make Earth at the center. I could put that at the end and see, how do people describe the earth, or how does the Bible describe the earth? I can look at what's happening upon the earth, all these things that creepeth upon the earth. And again, I get back to some of the poetry in the original text this way. This can be used for other things as well, besides exploration of a sacred text. Actually, one of the things that was inspirational for us to create this was a data set that someone uploaded on Many Eyes of personals ads. And it was called "I am married / female." It was a set of personals ads by women where they mentioned that they were married. And the word tree actually is a great way to explore this. You can start out with "I am." We could sort of click on "married." We can see the distinction between "and," "but," and "for." And start to really explore what is going on in this data set. And again, I think this gives you a picture of this data set that's distinct from a tag cloud, something that really lets you get to the center of the text in a different way. The word tree works off of repetition. It's really looking for phrases that are repeated very often. And that, it's not doing any complicated semantic analysis, but simply looking for things that happen over and over again as a signpost to what's important. That turns out to be a kind of enduring theme in ways to handle text visually. It's transparent because everyone understands repetition, but it can be very powerful. Let me show you another example. This is actually, let's not go to the PhraseNet yet. Let's talk about something called Chimera. So it turns out if you look at a lot of text, and legal boilerplate is a great example of this. If you look at a contract, it's not like your lawyer wrote that whole thing from scratch. Or if they did, you're not bankrupt. But what happens is the way something like a contract gets written is that people are constantly remixing, that they're taking from other contracts, they're adjusting to create something that suits the situation. And this is true of all sorts of text, but we all know about it as the boilerplate problem. And the question is there a way to visualize that? So the Chimera project aims to do that by taking a large collection of text and then looking for repeated passages. So one example data set that we used this on was a set of terms of service that we found on the web. We went to Bing, did a search for terms of service, got 1,000 representative terms, and then we were able to take something like this on the left, where you see just a raw piece of legal text, and on the right is the same text, but everywhere there's a passage that occurs somewhere else in this collection of terms of service, you see it highlighted in a different color. And the color is essentially randomly chosen, but related to the text it came from. So you can see, OK, a lot of this is boilerplate. That's fine. I can also arrange this another way, where I can kind of create this faux 3D aspect and arrange these in stacks to show you just how much repetition there is. And now you get this idea, these sort of skyscrapers of boilerplate showing you what parts of the contract really have a lot of repetition. Those are probably the innocuous parts, quite likely. That's what everyone agrees on. And if you're negotiating a contract, you might want to focus on the parts that are unique. There's a little piece of trivia I found a bit ironic, actually, which is looking through these contracts, which were the snippets that were most commonly repeated and taken the same from one contract to the next. It was the sections on copyright law. Go figure. Maybe the lawyers can explain it to me. What else can we look at? Here's the many eyes terms of service. Here, you can see those skyscrapers are very high. What else could you use that for? So you could ask, is there anything going on beyond the sort of routine copying and remixing of these contracts? Well, it turns out that one of the things we looked at, the terms of service for Ning, so a very well-known site, quite prominent creation for social networks, actually matched almost entirely a more recent site. And there may be some business relationship between these two sites, but I don't know of it. It seems more likely that the new site could have copied almost wholesale the old terms of service. Again, whether that's bad or not, I don't know. But it's very dramatic to see just how much of this IASG terms of service seems to match the Ning terms of service. That can make you look for other things as well. So obviously, plagiarism is one thing that you can think about in general. But what about other types of copying? So this is an example of being inspired by people from another field. We talked to a journalist named Chase Davis, who was very interested in what he called clone laws. So there's kind of an interesting phenomenon in state legislation right now that if you put yourself in the place of a state legislator, what is your life like? Well, you're ambitious. You want to pass laws, but you're also really overworked. It might be kind of a part-time position. In 38 states, you have no paid help. It's very difficult. It's not easy. What would make your life better? Well, if someone just handed you a pre-written law that you could pass as your own. It turns out that actually this happens a lot, that there are a lot of corporations or other interest groups who are able to spend a lot of money on crafting laws they'd like passed. And so there's a sort of unholy alliance that happens where interest groups will come up, craft the laws they want. They will then give them to state legislators, and they'll say, here, pass this as your own. It's fine. You don't have to credit us. No problem. And there's a bunch of organizations that do this. One interesting one is ALEC, A-L-E-C. You can sort of look it up. These places are sort of partly in the open and partly not. So the idea is, what if you could take a set of state legislation, run this tool through it to look for repeated passages, and say, could we find laws that are close to the same between different states? And then think about, were those really independently passed? So we got a sample data from Chase Davis. And sure enough, it turns out that when you do that, the results, it's not visually dramatic, but what you can see is that in this case, there was a law passed in Minnesota that matched a law passed in Alaska. Not exactly word for word, but in many, many, many passages. When you took some of the more distinctive passages and put them into Google, you would get taken to a website called the Firearms Freedom Act. The Firearms Freedom Act, it turns out, is this very explicit interest group creating model legislation. In some ways, they're fairly open about it. They have a website. It's almost like open source law, because they'll have people writing in saying, I think your model, there is a loophole here where, the government could take away gun rights in this particular thing, and they'll modify it and talk about it. But at the same time, it's not super open. It's not like you would have necessarily known about this without this kind of tool. So again, I think it's a very powerful use for very simple computation, just looking for repetition. But over a large enough corpus, it actually tells you something kind of fascinating. OK. That brings me to another thing. Again, this is sort of in praise of simplicity. Again, my training is really in math. I deal with computer science a lot. And there's sort of a funny thing. There's an instinct that I have that I think I share with a lot of people who spent time in computer science, which is, if you're given a bunch of text you have to analyze, what is your first instinct to do with it, to simplify it? It is to remove the stop words. I know I'm not alone in this, because when I go into Google and type remove stop words, that is, remove words like the and, I get more than 100,000 results of people also asking, OK, how do I do this? Should I do this? And it's something that I think computer scientists do without thinking. They just sort of, they're like, OK, that stuff is meaningless. But the truth is that text is not just a bag of words. These small words are indicators of style, indicators of things, how we're sort of framing issues. They're very important. This was first driven home for me in talking with Franco Moretti, who was describing when he was looking at, for example, titles of novels, how just looking at very simple phrases, a title like The Castle of Otranto, like the blank of the blank, that template to him was very meaningful. And this was a complete revelation as a computer scientist. I was like, wow, thinking about it later, I realized, okay, I guess I've read the stylometrics literature a little bit. I know there's some degree of meaning to this, but realizing that these very simple, small words hold so much meaning was kind of fascinating. And thinking about how you could use those templates led Fernanda and me to another visualization called the phrase net. So let me describe the phrase net. It's a little bit geekier than some of the things I've been showing. So I'm going to sort of ask your patience as I describe it. But I think there's sort of an interesting payoff here. So the idea is that you begin, I should say broadly, the idea is to take a text and expose sort of an underlying network that's in the text. And it's not like there will be one network in the text. It's more like this is something highly, very high dimensional, and you're projecting down in different ways. So the idea is you begin with some sort of template that has two blanks in it. So, some example templates that I'm showing here are x of y, x in y, x is y, which could match things like Castle of Otranto, living in Paris, sailor's bride. You have very, very simple lexical matching. The computer goes through, it matches these templates, super easy for a computer, super fast, and then it creates a network out of this. So if it sees a match, it creates nodes for each of the items that fill in a blank, and it creates an arrow to go between them. And then it uses multiple matches to generate a network out of this. So how does this work? Let me show you what you get out of this. So I actually want to, even geeky aside to the geeky part of the talk, is actually I want to talk a little bit about the layout method, because it's actually, I think, useful and worth thinking about. So we get a network of text of this, and the basic idea is you have words, you have connections between them. We want to make the size of the word tell you its salience, maybe the frequency in the network, the degree, something like this. In this case, I think what we're going to be showing is the degree. But there's sort of a couple of recurring problems that happen. And probably one of them, for example, is that you get a lot of so-called stars. So for those of you familiar with graph theory at all, it's like a star is if you have a node with a bunch of little degree 1 vertices coming out of it, things that are just attached to that node and nothing else. And frequently, you see these stars in graph diagrams, and it's a huge amount of visual clutter for what is really a very simple operation. It's just a set of things with one connection. A second thing is that when you're dealing with text, you'd like stuff to align as much as possible. You want your words to be sort of arranged in columns if you could manage it, just because that's easy to read. So what do? We sort of simplify our graph through a sort of structural equivalence relationship. So the idea is if you have a star, from the point of view of your graph layout, really all of these degree 1 nodes, these peripheral nodes, are identical. If I switch B and F, it's the same graph. So in a way, it's sort of stupid that you have this star where everything gets a different angle. It's all it looks like you've got 8 different pieces of information here, but you really only have one piece of information. You've got these 8 things that are all connected to that one node. So what we do, and this is work both with Fernanda Viegas and Frank Van Ham, is we simplify this down. And this is an operation you can apply sort of all over your graph, and it creates a radically simplified view of the graph. So it's a trick that is designed to make your output easier and your layout easier. OK, so with that, what do we get? Let's take a look at literary analysis. So here's a bunch of titles of novels, British novels, again, thanks to Moretti. And what if we take these novels and look at the pattern X is Y here? So take a moment to look at this. What are the words that really stand out here? The biggest word is daughter. That is in light type because arrows are going in. So daughters are owned by people in some sense. There's the merchant's daughter, the farmer's daughter. We also see woman, soldier, father. These are, woman owns things. It's the woman's love, the woman's life, unlike the daughter's. We can zoom in on particular aspects of this. So it's very dramatic to compare wife and bride. The poor brides, it's like the pirate's bride, the bandit's bride, the sailor's bride. These are not necessarily the most desirable husbands, whereas the wives get ambassadors, bankers, and so forth. So it's kind of interesting just to see that come out through this very, very simple lexical analysis. What else can we see here? we could sort of do very simple entity analysis, looking for nouns, even though nowhere in this pattern does the idea of a noun occur. If we do the pattern X and Y here, so this is not a Boolean and, it's literally looking for phrases like Elizabeth and Jane. If we look at Pride and Prejudice, we see just by looking for that phrase, we get a network of, key characters in the novel at the upper left. We also, so there's a zoomed in view of that. We also can get networks of, for example, things like pride, vanity, these emotions, conceit, folly. And you start to get these interesting networks of meaning. And you could look at what is present, what is connected, what is absent from these networks. Again, I think to me, the big surprise here was the fact that by doing very, very simple pattern matching, such a sort of readable network would come out. You can also project, and I use the project metaphorically, in different ways. So again, taking Pride and Prejudice and looking at a different pattern, I can simply choose X at Y, and suddenly I get a completely different network where I see, the places. I can see Pemberley, Netherfield, Longbourn, as central gathering places of the novel. Again, just by creating this network, looking for repetition. You can play little games with this. If you go to the King James Bible and use the phrase X begat Y, you get a sort of quasi-family tree, slightly messed up because people share names and there are complications and so forth. But it's an interesting way of looking at the text. If you speak regular expression language and are willing to go there, you can do other things with this same technique. You can just look for alliteration, for example. So in Walt Whitman, here we get a network of things with the same letter. And you can say, okay, not too many R's, but boy, did he love those S's. The stars silently shining, the summer sun setting, and so forth. All of that comes out in this view. Okay. And again, so I guess showing a sort of a comparison. Here we have the New Testament and the Old Testament looking at X of Y. Again, you can think of this as sort of possession or some sort of power relation. And you can see very clearly the difference between these two texts. It becomes a sort of comparison tool that is, I think, quite revealing. All right. So I'm going to move from the Bible to something in a different direction and talk a little bit about art and how you might use some of these methods sort of for artistic means. So Fernanda and I, at one point, got very interested in looking at how the body is talked about in culture. It's sort of, is there a way to get at that statistically? And we did an entire project called Flesh Map based on that. And I want to talk about a couple of sections of that project. So one question is just about lyrics. How do we sing about the body? Luckily, data is plentiful these days. You can go online and get a lot of song lyrics. You can find ways to classify songs. So it was no problem to gather the raw data for a little artistic experiment where we got 10,000 songs, their lyrics. We classified them into 11 genres. And then in one big brainstorming session, we came up with 83 body part words. And put those into a computer with not a whole lot of coding, and you can start to create little tables. Here we see for folk songs, for example, I can get statistics like throat is mentioned in 1.64% of the songs in our sample. Not hugely illuminating. You might try to graph this. Here's a bar chart of the same data. Again, I think you can argue about exactly how much value you're getting out of this chart, although there's very little chart junk there, so that's a benefit. But what if you decide to really kind of spice it up and say what you want to be seeing if you're looking at a chart of body parts is the actual body parts? Why read those little tiny faint labels at the bottom anyway? So let's do that. And so this was the method we came up with. This is a bubble chart showing in folk songs how many times different parts of the body were mentioned. So you can see it's actually a very gentle genre that immediately leaps out at you. I think the previous two views didn't really tell you anything without a lot of squinting. But here you can see this is gentle. There's the eye, the face, the lips. I'm going to just parenthetically add, we frequently get asked by people, how come the heart isn't in there? Where is the heart? And the answer is, heart gets mentioned a lot, but we stuck to external organs because we felt like with photographic imagery, a big bloody heart would not be very conducive to the idea of love, which it usually represents. But here, you see, again, very gentle. What about blues? Pretty much the same. Actually, in fact, surprisingly similar. Although here you see hand, very big. The knee is big. Maybe it's because you're asking people to give. People need a hand. They're down on their knees. I don't know. You can start to spin stories around this. But then you can ask about other genres. I mean, what about heavy metal, for example? So actually, the interesting thing about heavy metal is that it does have a diversity of body parts, but it's almost the same as folk in some ways. Eye is huge, face is huge, head is huge, hand is huge. There's actually sort of a lot of commonality there. It turns out that of all the genres we looked at, only one was a complete outlier, and that was hip hop, which was very, very dramatically different from the others. And what's funny is you can actually make a chart and compare these sort of directly in a matrix like this. And you can sort of see right away, okay, there's basically, there's eye music and hand music, but the eyes typically have hands, doesn't their number 2, hands with eyes is number 2. But again, hip hop is really the outlier. So again, it's sort of an interesting way at looking at this cultural artifact in a way that sort of induces people to start tell stories around this. Okay, so this is one way that you can look at sort of the body and culture. You might say, is there a more direct way? I mean, what is it about bodies? I mean, they get touched. Is there any way to sort of look at how we feel about our bodies, to think about desire, think about erogenous zones? Because really, it's like our bodies are complicated. There are lots of different places on them you could be touched. And you can start to wonder, how do we feel about this? Where do we want to touch people? Where do we want to be touched ourselves? And these are intimate questions. They're not questions. It's easy. You can't just go out on the street and ask people because they would hit you. But it turns out this is the age of the internet, where finding out intimate material is actually quite easy. And we have this miraculous invention, the Mechanical Turk. Can I see a show of hands? How many people have heard of the Mechanical Turk? OK, so I'm not going to explain it at great length, but let me just sort of say very quickly, the idea behind the Mechanical Turk is it's a service run by Amazon that lets you ask people to perform very simple tasks. The name comes from the sort of famous episode in history where someone claimed to create this chess-playing robot that I guess looked like a Turk or something. And it was this big mechanical Turk that would like beat you playing chess. It turned out it had some midget grandmaster in it. It's sort of disappointing. The idea behind Amazon is to kind of replicate that it's a robot, but it's not feeling. It acts like a computer in the sense that you can just call out like a subroutine to it, asking questions. But it's really giving those questions behind the scenes to human people who get paid for answering them. So typical tasks on here are things where you show 2 photos and say, are these items different? Can you tag these images and so forth? And people get paid a small amount of money to answer these. We teamed up with a company called Dolores Labs. I think they've changed it. They might be Crowdflower now. And created our own task that was not just about sort of are these 2 items the same, but was a little bit more complicated. It would show pictures of naked people, and it would walk people through all these different points on the body and ask them to rate on a scale from 1 apple to 7 apples how much they wanted to touch that part of the body in a lover versus how much they wanted to be touched there themselves. It turned out you did not have to pay people very much to do this task, interestingly. And so the question is, what happens when we looked at that data? We ended up getting hundreds of people making hundreds of ratings of, all sorts of parts of the body. And what happens when you actually view it? So this is one that, it's on the web. So you guys can go look at this yourself. But I'm going to walk you through here. And we can create these very simple heat maps that show, in broad outline, the parts that are especially interesting to be touched or to touch are not hugely different from what you would expect. So there's a little construct validity. Although I have to say, it was very interesting watching the blog reaction online, even to images such as this. Because people would look at sort of the yellow parts where people really want to be touched, the blue parts where not so much. And bloggers would write about this as if there was some sort of objective truth to it. And we would see people who would say, oh, this is all completely obvious. And we would see other people saying, this is ridiculous, their study is flawed, look at where the feet are. And all I could think is like, OK, you're not telling me about the study. You're not telling me about the project. You're telling me about yourself in an interesting way. So it's interesting. You can also play games where you're kind of comparing things here. So for example, we could say, all right, what about let's look at women being touched. We can say, OK, there's desire to be touched versus where men want to touch women. It's actually sort of comparable, but what you see is the back of the neck is sort of the key area where women want to be touched there far more than their lovers want to touch them there. You actually can see sort of inverse phenomena looking at men, where women have a much broader range of interest than men seem to in being touched, according to our study. So this is actually something that you can, as I say, you can go online, you can play with this. It's quite interesting. There's, I should say one thing about the data is that it's a little bit limited still. Because of our sample, we got some data on all of our data that was statistically significant was on heterosexuals. So it's all straight, not gay. We had some data on other countries, but again, not enough to make statistically significant conclusions. So you could say that further research is needed here. But I would welcome someone going back and doing that. You can look at this in other ways as well. I think Fernanda and I are both fascinated by cartograms, those maps of the world where the size of countries will grow or shrink according to some dimension that you're measuring. You can do that too on FleshMap. We can say, let's just look at where people want to be touched here. And we can sort of shrink. We can do this both with men and women. We can do front, so forth. See things come in. It can be kind of dramatic. We can sort this out. One of the interesting things, again, though, is like if we go back to the back here, is we'll actually see the #1 place for women on their back is apparently the back of the neck. And again, all I can say is this is what the study said. So it becomes, again, it's sort of an interesting way of looking at sort of data that I think is not traditionally associated with visualization. OK, so that is one way of looking at desire. Let's talk about something even more abstract. And this is really, I'd say, purely artistic, but does begin to touch on some sort of cultural issues. And that is color. So Fernanda and I first thought about visualizing color when we were approached by Wired magazine to create a visualization of their covers, or actually a visualization in honor of their anniversary. And we thought of their covers as something that was very distinctive. And this was, I think, in 2008. And I don't know if you had done your own cover visualization yet at that point, but this was sort of an interesting thing. So we were looking at these colors, and we wanted to abstract these a little bit. And we said, OK, is there any way that we can extract the key colors from an image, just a few colors, and then display them in a simple way? And we came up with an algorithm that essentially looks at all the pixels in an image, creates a sort of three-dimensional histogram, or histogram in the three-dimensional color space, and finds peaks in that histogram and says, OK, those are the key colors to look at. If we do that and then draw the results as concentric circles, we have a way of taking an image and just reducing it to essential colors, which you see here. We can then actually start looking at patterns in these colors. So for Wired, we created this graphic that was based on, this is a layout of all the magazine's covers over time. So what you're seeing here is every row is an individual year of publication. And they're laid out in months from January to December. So time goes left to right in each row. So the row at the, or the column on the far left is entirely January. The column at the far right is December. And looking at this, it's like you can start to see some patterns. But does anything come out when you actually make it more abstract? And the answer is, yeah, you do start to see some stuff. Now, there is a bunch going on here. I mean, this is a whole complicated design piece. It's got a silver background. It's got their logo. The circles are varying according to circulation and so forth. But if you just look at the colors, you do start to see interesting patterns. Like, there's something about January. They like to start the year on a clean slate, it looks like, because they have these very, very simple colors. You can also see there are times where they seem to really like light covers. But then lately, they've gone to sort of dark covers. What does that mean? I'm not the art director at Wired, so I don't know. But as we've seen, it leads to a lot of very interesting questions with Lev's work. So this, again, it's sort of an interesting case of, this is not something that I think is traditionally used, in the hard sciences, this type of visualization. And I don't know if Tufte would approve of this or not, or whether he would even care. It may be sort of so outside his purview. But to me, it's actually a very interesting phenomenon, the idea that you can actually visualize color. I want to end with an example of using this to show colors changing over time in another way. This was a piece that Fernanda and I did for Boston Magazine. They were interested in looking at sort of the ebb and flow of seasons in Boston. The commission came right at the end of winter, so everyone was looking forward to spring so much. And so what we decided to do is to take pictures people had taken. This is Boston, so we picked like a nice landmark, the Boston Common, and said, let's look on Flickr at pictures taken of the Boston Common for each of the months of the year. We'll take hundreds of pictures for each month and just see, is there a pattern in the colors that stands out? Or is it all just random noise, ultimately? And the answer is no, you do see a pattern. So what you're seeing here is it's laid out sort of like a clock or a wheel. Winter is at the left, so January is at the extreme left. Summer is at the extreme right. Spring is at the top. Fall is at the bottom. And if you look at this, what we've done is we've taken that same color extraction algorithm that we used in Wired. We extracted more key colors this time. And then plotted the frequency of each of these colors on the stripe. We did some editorial rearrangement here. Again, this is not hard science. We took out some of the blacks, which just kind of didn't look good, frankly. We moved the grays to the outside to make the sort of colors, the sort of saturated colors easier to see. And you start to see patterns. You can see the whites of winter. I should actually show that here we have labels here. This might make it a little bit easier to understand sort of how the time is laid out. But yeah, it's very distinctive. Winter looks cold. It's these cold colors. Fall has these, beautiful, autumnal leaf colors. In spring, you can actually see this stripe that is the flowers. And they really are the flowers. If you go back and look at the Flickr photos, you can verify that's where that color comes from. So I want to end there. I think we've left 15 minutes for questions. And again, thank you for, hearing this sort of, as I said, thank you for hearing this thank you note. That I think there's a huge amount that the non-hard sciences have to teach visualization. Thanks.
Thank you, Martin. Thank you for this really fascinating talk and walking us through the process, how you think about the content, the questions that you ask through the content, and so on. As you mentioned, we have about 15 minutes for questions. If you would like to walk up to the microphones. Everybody seems to be overwhelmed. There's one.
So this may seem like a petty question and like a non-technical question, but whenever I saw a picture of a person in your show, they all read to me as white, and I'm wondering if that was part of your research design, or was that an oversight?
No, it's not a petty question at all. That's actually a really good question. It's an artifact of the sort of stock photography source that we had, essentially.
I'm not standing next to the microphone anymore. Are you interested in doing further research on how perceived race changes what people believe is attractive?
Yeah, I think it's very interesting. I mean, I think someone should do that research. I would, if I had time, I'd be interested. But yeah, I mean, honestly, I think you've put your finger on sort of a flaw in that work. But it's like one does these things and realizes, okay, that turned out to be sort of again, I would say you're absolutely right to highlight that. But it was sort of, in the world of multiple constraints of creating things, that was definitely a constraint that I think did have an effect. So yeah, I'd be interested in thinking about that.
Imagining a white user is
Yeah, I mean, the other thing that's interesting is I don't have data on the Mechanical Turk workers themselves. And I think that's an interesting question right there in trying to evaluate these things.
I wonder if you could talk about the subjective process of choosing a corpus. Like, what attracts you to a certain batch of data that you want to visualize?
That's a great question. I don't know that I have a very crisp answer to that, but it's, and in fact, I certainly don't have a very objective answer, but I can tell you what it feels like when I'm looking at data and I know I want to visualize it, is I just feel really curious. I'll just get some idea of, like, okay, what would that look like if you looked at all the photos? Like, over time for the Boston Common, would you actually see a pattern, or wouldn't you? And then you start thinking quantitatively, like, how strong would it be? So in a sense, I think what you're looking for is, this question that you just suddenly need to know the answer to. One of the things is, in visualization, it's interesting. A lot of what comes out ends up being kind of quantitative. And things where you can sort of take something that's not quantitative and look at it quantitatively, there are huge pitfalls to that. But I think at the same time, that's a level of curiosity too. You want to know, it's like, is this a small difference or a big difference? I think in some ways it's a little bit like a journalist or a reporter, saying, okay, is there a story here? What is the sense of, will someone else care about this? Do I just want to know what's going on? Is there a mystery? I think with the work that Fernanda and I did on Wikipedia, for example, I didn't show it here, but that was strongly motivated by this feeling of, like, wait a minute, Wikipedia shouldn't work, or it's like, it's very weird that it does work. And we just wanted to find out what the heck is going on. So I will say this, though, and this can be different from person to person, but for me, it's rare that I start out with, like, a particular image that I want to see. It's more that I have a data set and a process, and I'm curious what image will result from that process. If that makes any sense.
So maybe I can ask one question. In terms of looking at the data, one is the interest in the data, but then looking at the data very closely and to reduce it to the parameters, that makes sense to be visualized. I remember, for example, the project that you did, The Shape of Song, where it takes sort of a song and then looks at repetitions and so on. So what's the process where you find out what are the elements that are worth to be represented in a visual format?
Yeah, I think that's an excellent question, and that's super hard. And my hard drive is littered with failed visualizations, where basically, I tried something and it just was boring. I think, for example, with The Shape of Songs, a project on visualizing music, I spent a long time trying to visualize what key a piece would be in, and visualizing how that would change over time, and it was just terrible. It just didn't work. It looked ugly. Nobody walking by my screen would have wanted to stop and look at it. And so I think, if I knew the answer to your question, I would not make all those mistakes. So in some ways, it's a very trial and error process where you sort of sit there and you try a whole bunch of things, hoping that they'll work. It works in a couple of ways. One thing is, like, if you're doing an interesting visualization, you'll find errors in your data right away. And that actually becomes a very useful tool to tell that you're on the right track for looking at things in a new way. But the other thing is, like, people start to, if you're in any kind of office or even in your home and you're looking at family members, they'll start walking by your screen and they'll just be transfixed and ask you questions. So it's a hard thing, but I will say that you're right, that I don't try to visualize everything at once, but I sort of go through a list and kind of one by one think, okay, will this angle look? Will that angle work well, and so forth. I don't know if that...
Yeah, and I think that's, to me, is the fascinating part about your work, is reducing it to very simple parameters. But the outcome is really amazing because you look at then the body of text or the body of the data in a very interesting way. And it's stunning quite often what just with these few parameters, what you can actually visualize through that. So we have another question.
Yes.
Many of us here aren't computer scientists. I'm a business professor, entrepreneurship professor at Babson College, and really interested in visualizing new industry emergence, industry evolution. But just building a toolbox is beyond painful. And I guess, do you have any strategies or recommendations for people with a passion for this area, but they just don't have the tool set?
I think that's actually an incredibly important question. And I think there's very interesting work out there right now. I mean, I think there are a variety of ways of approaching that. So, for example, a past project that Fernanda and I worked on, Many Eyes, will let you sort of visualize data that you're willing to put up in public. There's actually a variety of sites now that will actually let you do that. There's, for example, Tableau Public is quite good. There's a site called Swivel that is good. That said, all of these sites are really aimed at creating, particular ways of visualizing data. And if you want something that's a little bit more flexible, currently, if you're a developer, there are a lot of libraries out there. But I think what is absolutely needed is a way for non-developers to be able to kind of compose visualizations themselves. And even I think what would be useful would be, templates that would sort of let people put together their own stories. One of the things that's interesting, if you look at sort of the history of bringing things that used to be on the desks of computer scientists into the hands of the non-computer scientists, is Excel. I think, or VisiCalc originally, spreadsheets. And that's one of the grand success stories for letting people do things that used to require programming, but now a lot of people will use without even thinking that they're actually doing something very sophisticated. And if you look at how people use these spreadsheets, there actually have been a lot of studies done. And typically, the way people learn them and create new spreadsheets is they'll look at existing spreadsheets and just make sort of small modifications. That they'll have like, oh, here's a template someone created of how to add up a bunch of numbers. And now I'll just make a small but flexible modification of that. So I think that is sort of the future. It's like trying to come up with ways to create sort of stories that people can kind of modify themselves and suit to their purposes. I will say it's a very complicated area right now. When the iPad came out and Apple got mad at Adobe or whatever and didn't support Flash, it's like technically there are a lot of complications. But I think that's a sort of a big important problem that hopefully we'll see work on soon.
So one other question in terms of how people deal with these visualizations, especially thinking about Many Eyes, because you've added more visualization tools over time, and just from looking at and observing how people have used it, is there a way that people have learned to read more complex visualizations? Because there's always a question, do we need sort of a new visual literacy in order to deal with visualizations that are becoming more complex or that tell us more about a data set in a new visual way?
Yeah, I think that's an interesting issue. And I break down visual literacy into two parts. One is reading, and the other is creating. Right now, and I'm just going to speak from my own sort of anecdotal experience at this point, because I don't have studies to back me up on this, but I'll tell you my intuition, is that when it comes to reading, we're not in bad shape. I actually think people are pretty good at reading graphs. There's some people who may like it more than others, but overall, once you see Hans Rosling show like moving scatter plots to general applause, we're there on reading. Like that's way farther than I think anyone would have guessed in the 80s. The place where I think visual literacy is really complicated is in creating, because the truth is it is completely possible to make wrong choices when you're making a visualization, and to use a pie chart when you should be using a line chart, or a line chart when you should be using a bar chart. And those choices are pretty subtle. One of the things that I'm hoping is that people can kind of teach each other. That was one of the hopes behind Many Eyes, that by doing visualizations in public, people would create a visualization and get feedback from other users about whether it was good or not. And that did happen to some extent. I think we're starting to see it in other cases as well. One of the analogies that I like to think about here is with desktop publishing. I sort of remember when the first Macintoshes came out and people started to actually be able to choose fonts en masse and do typography. It was really painful. Like, everything looked like ransom notes, right? I mean, there literally was a ransom note font. But I mean, it looked horrible. I also remember around the same time, like, knowing the difference between serif and sans serif in the 80s, and thinking that was some sort of esoteric knowledge. Today, that is completely assumed. Everyone knows how to do it. Everyone, puts together quite nice memos. It looks good. People don't make crazy mistakes like they used to. It's not like everyone's a brilliant graphic designer, but, if someone needs to write a report, it looks pretty good. If you look at resumes out there, they're not perfect, but a lot of resumes look really good. And I think what we've seen is a process over 20, 25 years where people collectively have realized, OK, here are the basic things you need to know about typography, and have kind of gotten it to some degree, certainly far more than they used to. I'm hoping the same thing will happen with visualization, that collectively, as it becomes part of the discourse and as people realize, OK, this is something that's powerful like a resume, it can help me make my case in life, that they'll learn how to do it. And so I'm hoping for education. There's another approach, which is automated creation of visualizations, which is interesting, but I feel like this is one that might be solvable by good old-fashioned human brain power. So.
OK, thanks a lot, Martin.
Great, thanks.